Today we're going to talk through the Chapter 7 review, so let's get rolling. On your test coming up, you do get to use your little cheat sheet that has the different definitions of x-intercept, etc. So if you have that, you may want to have that as we cruise through here. First thing, x-intercepts. If you look at your cheat sheet, it's value of x. That makes the top 0. They are x, y coordinates. We do need to have good notation. My pen quit writing. Okay, so make sure you have good notation. It is an xy coordinate. If x is a -2, that makes my y value 0. If x is a +1, that makes the y value 0. They are xy coordinates. Do not put x equals -2. That is the equation for a vertical asymptote as an x equals. These are xy coordinates. Notation matters. Okay, y-intercept. Value of y when x is 0. Putting in 0 for x gives me, I don't need to write all that out. You're smart like that. Putting in 0 for x gives me 0 plus 2, which is 2. Putting in 0 for x gives me 0 minus 1, which is a -1. Multiply them together, and I get -2. On bottom, 0 plus 3 is a +3. 0 minus 2 is a -2. I multiply them together, I get -6. -2 divided by -6 is a +1/3. Again, it is an xy coordinate. This time, x is 0, and y is 1/3. I'm going to go ahead and graph those. 0, 1/3, 1, 0, -2, 0. Okay, vertical asymptotes. Values for x that make the bottom 0. These are x equals equations. X equals -3, x equals +2. And again, I'm going to go ahead and graph that one, +2 and -3. Okay, so there's my vertical asymptotes. Horizontal asymptote, comparing the degree of the top to the bottom. If I were to FOIL this out, I'd have an x squared on top. I would have an x squared on bottom. Looking at my cheat sheet, if the degrees are the same, my horizontal asymptote is the ratio of the leading coefficients. This would be 1x squared and 1x squared. 1 divided by 1 is 1. My horizontal asymptote is not 1. It is y equals 1. It is a equation of a line. Notation matters. Okay, hole. If there's a factor on top and bottom that's the same, we have a hole. We do not. Write the word none. If you leave it blank, I'm assuming you don't know the answer or how to find it. Okay, let's get your graph. Here's what I like to do. I have 2 vertical asymptotes. So there's 3 parts. There's one part over here, there's one part in the middle, and there's one part over here. I like to start on the right. It doesn't matter. You can start wherever you want. That's just what I do. Okay, so I'm going to start over here. I know as x goes to infinity, my graph must approach this horizontal asymptote. So either it comes from the bottom approaching the horizontal asymptote, or it comes from the top and approaches the horizontal asymptote. I know as I get close to +2, my graph must go to either infinity along this asymptote, or it goes to -infinity along this asymptote. That's the definitions of horizontal and vertical asymptotes. What happens at infinity, and what happens as we get close to my vertical line, it goes to infinity. Okay, so let's just talk through a scenario down here. If my graph comes from here, it has to pass through the x-axis in order to approach that horizontal asymptote. It can't. Why? Because my only x-intercepts are right here. My graph must come from the top along that asymptote. Where it turns, I don't really care. We could plot some points and get it exactly, but for this class, all we care about is the shape. Where is it at? It's up here. What does it look like? Something like that. Okay, in the middle. If it goes to infinity on the right-hand side of 2, then when I go to the left-hand side, it's got to go to -infinity. And we talked about unless the factor squared and all that stuff, but again, that's for a different class. So for now, if it's on the right-hand side, if it goes to infinity on the right-hand side, it'll go to -infinity on the left. Just realize when you get to next year in pre-calculus, there will be times when they both go from the same direction, and that would be if the factor that gives me the vertical asymptote is squared. Okay, so if this would have been squared right here, then it would have both come from the top. Okay, but that's for next class. But I just don't want to tell you something that's going to change next year. Okay, so for this class, it's going to come from the bottom. It's got to pass through that point. It could come up and go through the asymptote. I don't know if it does or not. I don't really care. But it looks something like that. How do I know? Because it has to hit this point. It has to hit this point, and it has to hit this point. The 3 points we graphed by x and my y-intercepts. Okay. Sorry, I've been talking kind of fast. Going to the right-hand side, it goes to infinity, negative infinity. So on the left-hand side, it's got to go from positive infinity. Comes down, turns, and approaches the asymptote. We also know same logic as on this side. If I were to come from this side, it would have to cross to the x-axis, and it doesn't. So for several reasons, it has to be up here. And I get it. This one is not as smooth as that one, but we're not being super picky. Does your graph, where's your graph at in these different regions? Okay, over here, x-intercept, value for x that makes the top 0. That'd be 0. Y-intercept, put in 0 for x, and we get 0, right? Because 0 on top divided by a -9 on the bottom is 0. And I knew that because it hit the origin right there. Okay, vertical asymptotes. Got to factor the bottom. Bottom factors into x minus 3, x plus 3. I get it. You probably don't have to. You could probably see that because you've seen this equation a bunch, but I factored it just so we can see it. X equals 3, x equals -3, and again, they are x equals equations. Trying to draw a straight line here. Whoa, that's not straight. I don't know why drawing straight lines hard for me with this Wacom tablet. All right, so here's my 2 vertical asymptotes. I'm going to go ahead and graph the xy intercept. Looks like that guy right there. Okay, degree of the top is a 1. Degree of the bottom is a 2. If the top is smaller or if the bottom is bigger, my horizontal asymptote, if you look at your little cheat sheet, is y equals 0. So I have a horizontal asymptote cruising across at y equals 0. You may say, well, how come it can cross a horizontal asymptote? Remember your graph, the definition of a horizontal asymptote is what happens at infinity and negative infinity, not what happens locally. How big is locally? It just depends upon the graph. Okay, but can it cross through the horizontal asymptote? Absolutely. Can it cross through a vertical asymptote? Absolutely not. This is values that x cannot be. Okay, y will approach 0 as x goes to infinity, but it can be 0 somewhere. Your x or your x values for vertical asymptotes, it'll never happen. It'll never cross through that. You can't divide by 0. Okay. All right, we have 3 different parts. Once again, we have 2 vertical asymptotes. So we have a graph over here, we have a graph in here, and we have a graph over here. It has to approach this asymptote. It has to approach this asymptote. So it's either up here or it's down here. Think about when x is bigger than 3. How about 4, 5, 6, 10? If x is bigger than 3, this is positive, right? 5 minus 3 is positive. If this is bigger than 3, this is positive. If this is bigger than 3, this is positive. I have all positive values. My graph is up here. If it goes to positive infinity on the right, it'll come from negative infinity on the left. It has to pass through that point. Sorry, trying to make it smooth. All right, so the question is, does it go back down or does it go back up? Let me get rid of all. Oh, too far. Sorry, I don't like my graph. I'm gonna start over. Okay, it can't turn and come back down. Well, let me rephrase that. It can and turn and come back down. If this was an x squared up here, it would have touched and gone back down, just like it does with a polynomial, right? If you have a 0 that squared has a multiplicity of 2, it touches and goes back down. Okay, so it can, it just doesn't. This is a 1 up here, so it passes through. So it's going to come up here, kind of look like a cubic, and approach that asymptote up there. Why can't I draw a straight line today? Sorry, folks. All right, if it goes to negative and positive infinity up here, it comes from negative infinity down here and approaches that asymptote. Let's just double check. plug in values that are less than negative 3. If it's less than a negative 3, that makes that negative. Less than negative 3 makes that negative. Less than negative 3 makes that negative. I have 3 negatives, which makes my answer negative. All the different rules support each other. It looks pretty good. All right, we're done. Oh, sorry. No, I'm not done. Got to write the word none. There's no factors on top and bottom that are the same. Now we're done. Question 3. I didn't make them factored, so let's factor it. First question in factoring. Is there something common in all 3 terms? Yes, there is. There's a 2. Factor out the 2. Now refactor that x squared minus x minus 6. We've seen this in a bunch. Super common expression. I want factors of 6 that will subtract to give me 1. 3 and 2. I want a negative 1, so the 3 has to be negative. We just did one kind of like that. Difference of perfect squares. Hopefully that's just like automatic. We don't even have to think about it. Factors of 4 that subtract to give me no x's in the middle. There's no x's here. That would be my factors. I have an x plus 2. I have an x plus 2. They go away. And so my simplified expression is that. I've told a few people to come in and ask about a whole. Recognize that this is just 1. X plus 2 divided by x plus 2 is just 1. These 2 expressions really are the exact same thing because I'm just multiplying this expression times 1. This expression times 1 is this expression. But this original expression does have the 2x plus 2 factors. Based on that, x cannot be a negative 2. So although it can in this expression, and I will get a y value, it can't be in the original expression because these 2 factors are there. So why am I saying all that? Because where the whole occurs is the value for x that makes the canceled factor 0 plugged into the expression, the simplified expression. And that will give me the y value that this passes through, but really doesn't pass through. It's where the hole's at. Okay, so just plug in some points, or a point. Plug in negative 2. I get negative 5 times 2 is a negative 10. Plugging in a negative 2, I get negative 4. Negative 10 divided by negative 4 is a positive 2.5. Okay? X-intercepts. Value for x that makes the top 0. XY coordinate 3, 0. Put in 0 for x. 0 minus 3 is a negative 3. 2 times a negative 3 over 0 minus 2, which is a negative 2. Negative 6 divided by negative 2 is a positive 3. Vertical asymptote. Value for x that makes the bottom 0. X equals 2. Degree of the top is a 1. The degree of the bottom is a 1. They are the same. It's the ratio of the leading coefficients. 2 over 1. My horizontal asymptote is y equals 2. Put all that stuff on the graph. Horizontal asymptote cruising across here at 2. Vertical asymptote cruising down here at 2. X-intercept 3, 0. Y-intercept 0, 3. Whole negative 2 and 2.5 sitting right there. It is an open circle. My graph must approach this asymptote. It must approach this asymptote. That one's pretty easy. Not that. Don't cross the vertical line. My line comes up here, passes through that point. Probably a little smoother. Man, I'm having a hard time graphing lines today. All right, coming from here, if it was on the bottom, now it's coming from the top, which makes sense. It's got to hit that y-intercept. It's got to kind of pass through the hole, and it goes along the horizontal line. There's my graph. Question 4, x-intercept. Value for x that makes the top 0. 3 will never be 0. 3 is 3. There is no x-intercept. Put in 0 for y. 0 minus 2 is a negative 2. 0 plus 1 is a positive 1. Positive 3 divided by negative 2 is a negative 1.5. Vertical asymptotes, values for x. We'll make the bottom 0. They are x equals equations. We've talked about that a bunch. Degree of the top is a 0. There's an x to the 0 power sitting right here. Degree of the top is 0. The degree of the bottom is squared. Bottom is bigger than the top. Horizontal asymptote, y equals 0. There are no factors that are the same on top and bottom. Plot my points. 0, negative 1.5. Y equals 0. Sorry, I jumped down. X equals 2. X equals negative 1. And that's all. So my graph over on this side of the vertical asymptote is either on the top or the bottom. It's either positive or it's negative, and it looks like one of these graphs. Same logic, if I put in something bigger than 2, this will be positive, right? Something bigger than 2, 2 minus, wow. Something bigger than 2 minus 2 will be positive. Putting something bigger than 2 makes that positive. That's always positive. It's up here. And once I know where one of them is at, the rest are pretty easy. Goes to positive infinity on this side. It comes from negative infinity on this side. It has to pass through this point and approach that asymptote. It cannot turn and come back. Whoa. Hopefully you said, wait a minute, Minogue. It has to turn and come back down because it cannot cross to the x-axis because there is no x-intercept. Let's see what he just said. I was going to cruise up here and pass through the x-axis. There are no x-intercepts. So when it hits this negative 1.5, it's probably going to be before that, right? Because of symmetry, if it really is like a parabola-looking shape, it's going to go above it. That will not be the vertex. We're not going to be picky, but we might as well, if we can, be as accurate as we can. Wow, sorry. My pen, well, I can't blame it on my pen. It's me. Okay. If it goes to negative infinity on this side, it goes to positive infinity on this side. It's going to come from here, and it's going to go like that. Double checking my work, plugging in a negative, like, if this is negative 1, plug in like a negative 3, makes that negative. Negative 3 makes that negative. Negative times a negative is a positive. This is always positive. A positive divided by a positive is a positive. We really are above the x-axis, which is my horizontal asymptote. Okay, I know that's fast, but we have a lot to get through. If that makes no sense, come see one of us. All right, different kind of graph. Notice there's no plus or minus on these. Okay, this is what's called an inverse function. My horizontal asymptote is the value that's being added or subtracted. It is an equation. My vertical asymptote is just like before. Value for x, that makes the bottom 0. Plot those 2 points, or not points really, but those 2 lines. My domain, pretty easy. X cannot be whatever the vertical asymptote is. X cannot be a negative 1. You can write the fancy notation if you want it. Value for x such that x is not equal to negative 1. I don't require that, but you can if you want. Okay. Range, y cannot be the horizontal asymptote. Now I'm just going to look at y equals a negative 4 to the x power. Ignore this, ignore this. Just look at this. And I'm simply going to plug in the values 4 and 1. Whatever's up here, I'm going to plug in. So if x is 1, 2, 3, 4, y will be a negative 1 because a negative 4 divided by a positive 4 is a negative 1. Plug in 1. If x is 1, y is a negative 4. 1, starting from here, 1, 1, 2, 3, 4. And there's 2 points. That's enough to get me a good shape. Go the other direction. Plug in a -4. -4 divided by -4 is a positive 1. 1, 2, 3, 4. 1, 1, 1, 2, 3, 4. And I get the same graph over here just on top. The bigger this number is, the further out this will be away from the shifted origin. Okay? All right. Horizontal asymptote, y equals -4. Vertical asymptote, x equals a +3. What makes this 0? And then whatever number's sitting there. -4. 1, 2, 3, 4. +3. 1, 2, 3. Y equals 5 over x. If x is 5, 1, 2, 3, 4, 5, y is 1, counting from my shifted xy axis. And again, this is not the xy axis. It's my reference shifted xy axis. This is still the xy axis. I'm just plotting from here. If x is 1, y is 1, 2, 3, 4, 5. Comes along this asymptote, smoothly transitions to that point, and on down. If x is -5, starting from here, 1, 2, 3, 4, 5, y is a -1. If x is a -1, 1, 2, 3, 4, 5, y is a -5. Simply plugging in the 5 and 1, -5 and -1. And I get my graph that looks something like that. And I just cannot draw a line this morning. No, it does not go back away. All right, we good? Hope so. I can't hear you say yes, so I'm assuming we're good. All right, simplify. Division becomes multiplication. The left-hand side fraction is already factored, so I'm going to leave it alone. Remember, when we multiply, factor, factor, factor. You cannot do that right there. Okay? You must factor everything first. Okay, to divide by a fraction, you multiply by the reciprocal. So I'm going to flip this over and factor at the same time. We can do that. Factors of 2 that add to 3 would be 2 and 1. I need a +3, so they're both positive. Factors of 3 that give me 4, 3 and 1. Now that I have all of these factored, these are things that are multiplied together. When things are all multiplied together, now I can cross simplify or simplify straight up and down. Anything on top can cancel with anything on the bottom when it's in multiplication format. X plus 1, X plus 1, X plus 2, X plus 2, X plus 3, X plus 3. Final answer, X minus 1 divided by 1, which is just X minus 1. When these cancel out, they do not go to 0. They go to 1s, because X plus 2 divided by X plus 2 is simply 1. Same for all the other factors. Question 8, factor, factor, factor. What goes into x squared and 5x? An x. What goes into 3x cubed and 15x squared? A 3x squared. What's left? An x minus 5. Multiplication, do not flip it. What goes into all three of these? 6. And I get x squared minus x minus 2. Leave the 6 alone. Factor the inside mess. Factors of 2 that subtract to give me 1. Well, there's only one option, 2 and 1. I need a -1, so the 2 is negative and the 1 is positive. What goes into 4 and 8? That would be a 4. Anything on top can cancel with anything on the bottom. I have x squared, so I have 2 x's being multiplied together. I'm going to take one of them and cancel with that guy. So I still have an x sitting down here. Don't forget him. He's still down there. Okay, we can do this 2 ways. 3 times 4 is 12. 6 divided by 12 is a half. That's the first way to do it. Or you could have just said these reduce and these reduce, but anyways, we get a half. So we get a 2 on the bottom. I have an x on the bottom. All these are gone. We canceled that. I have an x plus 1 on top. And that's all. Done. Factor, factor, factor. You must factor before you simplify. Don't multiply first. Okay, don't multiply, make this x to the fourth, and that would be just a mess. Okay, that's not where we're headed. Factor, factor, factor. Okay, when I add or subtract, I need a common denominator. My common denominator must include all the denominators of each fraction. My common denominator must have an x minus 1. My common denominator must have a 4. And that's it. So, what is in my common denominator that was not in the original denominator of each fraction? What is in the common denominator that's not in this denominator? A 4. So I'm multiplying the top by a 4. What is in the common denominator is not here? An x minus 1. So I get 5x squared minus 5x. Multiplying this by x minus 1. Distributing it, I get 24 minus 5x squared plus 5x all over 4x minus 1. We should take a second and try to factor this and make sure it doesn't have an x minus 1 in it. It's pretty obvious it doesn't, so I'm going to stop and assume it doesn't. Same thought process. Common denominator must contain each of the factors of each of the denominators. It has to have an n plus 1. It has to have an n minus 7. What is in my common denominator that was not in the original denominator? And I'm going to multiply this by n minus 1. No, I'm not. I'm multiplying by n minus 7. Got sidetracked by my cough. Multiplying this by n minus 7. I get 7n squared minus 49n. What's in my common denominator is not in the original denominator. How about an n plus 1? Multiply the top by n plus 1. I get 8n plus 8. This is addition, so nothing gets distributed over here. I get 7n squared. Combining like terms, I get negative 41n plus 8. All divided by n plus 1, n minus 7. And we're done with that section. Again, you should try to take a second, make sure it does not factor and so on, but it doesn't. Okay, question 10. A couple thought processes on question 10. What we've been doing in my class is multiplying everything by the common denominator. What's my common denominator? It's both of those. So I'm going to multiply this by 6x minus 4. Okay, this x minus 4, this x minus 4 cancels. 2 times 6 is 12. This 6, excuse me, and this 6 cancel, and I multiply the 2 times x minus 4, and I get 2x minus 8. There's one thought process. Thought process number 2. If I only have one fraction on each side, I can simply cross multiply. Which shows me I multiplied this first one wrong. How about an x squared, not a 2x? What are you doing to me? Okay, so x times x is x squared. Wow, what did I do? I did not do that correctly. X times x is x squared. Negative 4 times x is a negative 4x. I don't know what I did before. Sorry, I'm glad I tried it the other techniques to catch my mistake. So one way is cross multiplying, but here's a key thing on that one. There must be only one fraction on each side. That would not work for this over here. Okay, so the other technique is to multiply by 6 and x minus 4. Oh, I multiplied the 2. That was my problem. Okay, so these 6's cancel, and I get x minus 4 times the x. That's what I did wrong. All right, let's solve that thing. It's a quadratic, so let's set it equal to 0. factor. I won't say these always factor, but they're pretty much going to always factor. If not, you go to quadratic formula. Factors of 12 that subtract to give me 4 would be 6 and 2. I need it to be a negative, so it's a negative 6. I'm going to pick up my pace on the factoring because we should be able to factor by now. We've done it a bunch. All right, what values for x make this 0? How about 6 and negative 2? Do either one of these make the denominator 0? Nope, that'd only be 4. They both work. They're both answers. Common denominator. Well, I can't totally tell. Let's factor this thing over here. So I get x and x. It'd be really nice if it was the same as these here. Is it 3 and 1? Yes, it is. 3 and 1. So I get x minus 3, x minus 1. So my common denominator has to have x minus 3 and x minus 1. So I'm multiplying everything by x minus 3 and x minus 1. Okay, I'm going to get rid of this so it doesn't confuse us. Multiplying x minus 3 times x minus 3, x minus 1 times this, these cancel, and I get 2x times x minus 3. These cancel, and I get 1 times x minus 1. Both of these cancel, and I get 2. And solve. Distribute. 2x squared minus 6x plus 1x minus 1 equals 2. Combine like terms. Factor. So how do I get 2x squared? How about 2x and x? Factors of 3, 3 and 1. So I have an option. A 3 can go here and a 1 can go here. Or vice versa. If I put a 3 here and a 1 here, I get 3 plus 2 is 5. That's not right, because I am subtracting these two numbers, because these signs have to be different. So 3 plus 2 is 5, but I can't add the 3 and the 2. I have to subtract them, so that's not right. Let's switch them. Putting a 3 here, I get a 6. Putting a 1 here, I get a 5. 6 and 1 also gives me 5. I need a negative 5, so it looks like that. X equals negative 1/2. X equals a positive 3. Going back to my original expression or equation, x cannot be 3 because it makes the denominator 0. That one goes away. All right, common denominator, 2, x minus 7. X minus 7's cancel, and I get 2 times that, which would be 4x minus 18. 2's cancel, I get x minus 7 times x, which would be x squared minus 7x. X minus 7's cancel, I get 2 times 5, which is 10. X minus 7 cancels, what's left? 2 times the top. 2's cancel, what's left? X minus 7 times the top. X minus 7 cancels, 2 times the top. It's quadratic, set it equal to 0. Minus 3x minus 28. 28. Factor. What makes this 0? X equals 7. What makes this 0? X equals negative 4. X can't be 7 because that makes that 0. That goes away. That's my only answer. All right. Common denominator. Can't totally tell. Need to factor this thing. Multiply by x and x plus 1. Get rid of this. X squared plus 1x is that, so it's going to cancel. I get a 3. This has nothing. There's just a 1 down here, so I have to multiply that. So that was, remember, it was this right here. So I have negative x squared minus x, multiplying a negative 1 times this. This and that are the same, so I get a 3. 3's go away. I'm going to factor out a negative 1. X squared plus x. No, let's factor out a negative 1x. We can do more than that at one time. was going to do it in 2 steps, but let's factor out a negative x over here. So I get negative x and x plus 1 equals 0. What makes that 0? X equals 0. What makes that 0? X equals negative 1. Going back to my factored form, x can't be 0. X can't be a negative 1. Neither one of these work. There's no solution. All right. Sorry, this recording's getting long, so I'm maybe going a little too fast, but hopefully not. Question 14. Frank can clean the garage in 3 hours. Becky takes 4 hours to clean the garage. How long will it take them to clean the garage together? So the first question we have to figure out is, what is our variable going to be? I'm going to let x equal the total number of hours. For both of them, number of hours to clean. Okay? So, the amount that Becky can clean, so if it takes x hours to clean, then x divided by 3 tells me the part of the garage that Becky can clean, and x divided by 4 tells me the part of the garage that, this is Fran, that Fran can clean. This tells me the amount that Becky can clean, and together they must clean the entire garage. The total amount of time divided by 3 tells me the fractional part of the garage that Fran can clean. The total number of time to clean divided by 4 tells me the fractional part of the garage that Becky can clean, and together they have to clean the whole thing. Back to solving. Multiply by the common denominator. 3 goes into 12 4 times. 4 times x is 4 times x. 4 goes into 12 3 times. 3 times x is 3 times x. 12 times 1 is 12. 3 plus 4 is 7. Divide. And x equals 12 divided by 7. Or 1 5/7, or whatever that comes out to be as a decimal. And go to our units. These would be hours. Hardest part, setting it up. 15. Garth can row 5 miles per hour in still water. Takes him as long to row 4 miles upstream as it does to go 16 miles downstream. How fast is the current? Okay. This is probably the hardest part. What piece of information do we know? Here's what I know. Well, we know a lot of things. That was not a good question. What piece of information do we know that allows us to write an equation? Here's what I know. It takes him as long to row 2 different things. Time. I know time. I know how long it takes. So I'm going to convert all this information into time to go upstream and time to go downstream and set them equal. Since I know 2 quantities have to be equal. What 2 quantities? Time. How long it takes him. So if I know that distance equals rate times time, I know that time equals distance divided by rate. Garth can row 5 miles per hour in still water. It takes him as long to row upstream as it takes to go downstream. So let's do that. Distance, 4 miles. Rate, going upstream, 5 miles per hour in still water. But we're not in still water. We're going upstream. So 5 miles per hour minus the rate of the current equals 16 miles downstream. Distance is 16. My rate is 5 plus the rate of the current. And what does my x variable represent? Rate of current. And solve. Multiply both sides. Let me just cross. We'll do it different. We'll cross multiply. How come I can do that? Because there's only one fraction on each side. So 5 times 16 is 80. 5 times 4 is 20. Adding 16, subtracting 20, dividing by 20. X is the rate of the current, what I just found. How fast is the current? 3 miles per hour. When I get done, I just have to look back and see, well, what was it I just found? Ask, what is the question? And if they're the same, I'm done. How fast is the current? X was the rate of the current. X is 3. I'm done. 3 miles per hour is the rate of the current. Okay. If you did not get that one and you were waiting to see how to do 15 before you did 16, hit pause. Try this one again. Now that you've seen it done once, try this one. Okay, as I read through here, I'm looking for some way I can write an equation. I'm looking for two quantities that are the same. A boat can go 240 miles downstream in the same time as it can go 160 miles upstream. Speed of the current is 5 miles per hour. What's this? Oh, now we have it backwards. So now I know the speed of the current, but I want the speed of the boat in still water. Okay? Boat goes 240 miles downstream, doing the same logic. Distance divided by rate is time. So the time to go downstream is 240 divided by downstream, right? So we're going downstream. So we're going to add the rate of the boat and the rate of the current. So this will be x plus 5, 5 plus x, doesn't matter in this case, equals 160 miles to go upstream, and it's going to be the speed of the boat minus the speed of the current. Same logic as before, cross multiply. 160x plus 800 equals 240x minus 1200. How about we go this way? Add 1200, I get 2000. Subtract, I get 80. There was an x hooked to that. I get 80x. Divide, and I get x equals 25. What am I looking for? Speed of the boat. What is x? Speed of the boat. Answer, 25 miles per hour. 17. How many milligrams of metal containing 45% nickel must be combined with 6 milligrams of pure nickel to form an alloy containing 78% nickel? How much nickel do we have? Okay, so the question is how many milligrams of metal? So I want to know X is going to be number of milligrams of whatever this 45% compound is. So how much nickel do I have? I have 45% of however much I have. Okay, how many milligrams of that must be combined? So I'm adding to that. Pure nickel, I'm adding to that 6 grams of nickel. Don't need to multiply by anything. It's 6, you multiply by 1, 6 grams of nickel. To form an alloy containing 78% nickel. 78% of what? How much do I have? Well, I have however much I have from the first 45%, and then I have 6 milligrams, which happens to be pure, but that's okay. I still have that much. There's my setup. Okay, solve. All right, so let's solve this thing. It's pretty much a basic linear equation. All of the ones before this have been quadratics, but this one's not. So it's just going to be combine like terms on the right-hand side. Distribute. 0.78 times 6 would be 4.68. Do some rearranging. How about we bring the 0.45x to the right? Gives me 0.33x. Subtract 4.68. Gives me 2.45. Divide. Nope, sorry. That's 1.32. Read my calculator wrong. Divide. And x comes out to be 4. Go back, look at your definition of x. How did we define x? We defined x to be the number of milligrams of 45%. Look at my question. How many milligrams? My variable matches what I'm looking for. I'm done. 4 milligrams of the 45%. Okay, question 18. 7 liters of an acid solution was mixed with 3 liters of 15%. Remember our equation I had on the board today. We want percent of the part plus the percent of part 2 equals the percent of the total. That's my thought process. 7 liters of an acid solution. So we don't know what percent, so 7 times x. Amount is 7, x is my percent this time. Was mixed, so I'm going to add to that 3 liters of a 15%, so 3 times 0.15, to make a grand total of 29% of however much I have. Well, I had 7 liters to start with. I added to that 3 liters, and so I have 10 liters total. In the first solution problem, we wanted to know the amount we're adding, and now I want to know the percent of concentration. So my variable is going to be percent concentration for the 7 liters. Okay, and again, back to a linear equation, just solve it. 7x equals 3 times, oh sorry, not equals, plus 3 times 0.15, which would be, what, 0.45, equals excuse me, 0.297 times, where'd it go? There we go, 2.9 is 2.9 times 10, which is, or sorry, 0.29 times 10, which is 2.9. I don't need to distribute that. I can just add that together, make that a little easier. Subtract 0.45, so 7x equals 2.45. Divide by 7, and x comes out to be 35%. So once again, here's my thought process. I have an amount times a percent for the first mixture, plus an amount times a percent of the second mixture equals an amount times a percent of the total solution that we have. That's your thought process. I can't say every time, but almost every time that's your thought process for the mixture type problems. Okay, R varies inversely. If R varies inversely, it is a constant of variation. How do they relate? Divided by whatever it's varying as. R varies inversely as t squared. So I put a t squared. If it varies inversely as t, it's just a t on the bottom. Okay, so don't let that confuse you. It's just whatever it's varying as is on the bottom, if it's inversely. And if it's directly, it's multiplication. Okay, plug in what we know. They say at time equals, R is 10 when t equals 2. Plug in 10, plug in 2, work it out. K is 40. Go back to my equation. R equals K, which we now just found was 40, divided by t squared. So there's my generic relationship between R and t. Find R when t is 10. So go back to my equation, 40, plug in 10, square it, and I get 440 over 100. What does that reduce down to? 2/5? 20 goes into both, yeah, 2/5. You can go to decimal if you want, 0.4. Either one, R equals 2/5 or R equals 0.4. That's pretty painless. Question 20. As I read my problem, remember back in question 16 and 17, 15 and 16, we knew that it takes him as long as and same time. So in these two problems, we set the times equal to each other. Is that the same for this one? Brett lives on a river 45 miles upstream from town. When the current is 2 miles per hour, he can row his boat downstream to town for supplies and back in 14 hours. Not the same setup. Now we know a total time. So my total time is 14. So just like before, though, I do want to rewrite my distance equals rate times time in terms of time. So time equals distance divided by rate. Brett lives on a river 45 miles upstream. Distance, 45 miles. If he's rowing, so he's upstream, right? So if he's going to town, he's rowing downstream. So the rate at which Brett rows, we don't know. The rate of the current flows is 2. So the rate of the system, the boat and the current together, is x plus 2. boat's traveling at X miles an hour, current's traveling at 2 miles an hour, the whole entire system's moving at X plus 2 miles per hour. Now he rows back upstream, so the time it takes to go back upstream, same distance, 45, same speed he's rowing, but now the current's pushing against, so you're going to subtract the current from how fast he can row. What is his average speed in still water? So my X is representing his speed in still water. Okay, I'm going to not write all that, just write speed of boat. But I mean in the calm water. Solve. Multiply both sides by the common denominator in order to clear my fractions. My common denominator must contain the denominators of each of the fractions. So I'm going to multiply both equations by x plus 2 and by x minus 2. The 14 is over 1, so there's no denominator there. Left fraction, the x plus 2's go away, and I'm multiplying 45 times x minus 2. Second fraction, the x minus 2's go away, and I'm multiplying by x plus 2. On the right-hand side, nothing goes away. I'm going to go ahead and not cheat, but just skip a step and multiply x plus 2 times x minus 2 to save a little bit of writing. Distribute 45 times x, 45 times a negative 2, 45 times x, 45 times a positive 2, 14 times x squared, 14 times 4. Have a quadratic, set that thing equal to 0. I'm going to keep the x squared positive, so I'm going to move everything to the right. I have 45 x's plus 45 more x's gives me a grand total of 90 x's. Moving them to the right makes them negative. So we have minus 90x. Negative 90, positive 90 goes away, so I just have that 56 over here on this side. Okay. Remember I said most of these will factor. If you don't like the looks of that, which I don't blame you, you can dump that into the quadratic formula, but I'm going to factor it just because to show you that we can. I'm going to divide everything by 2 because they're all divisible by 2. Looking at factors of 7, which would be 7 and 1. I need 90. So how do I get 90? Nope, sorry, I need 45. We divided it by 2. I need 45. So factors of 28 are 7 and 4, 2 and 14, and so on. This is negative, so I'm going to subtract these. So I'm going to put a 7 right here and a 4 right here. Whatever I put in this second parentheses gets multiplied by the coefficient of the x in the first parentheses, right? My outside terms. So that's 49. Multiplying the 4 on the inside gives me 4. Is 49 minus 4 45? Yep, on the right one. Now, my bigger product, notice how I said that, not the bigger number, the bigger product needs to match the sign I want. I want a negative, so my bigger product needs to be negative. It does end up being the bigger number, but think of it as the bigger product because it may not always be the bigger number. Okay. What makes my first parentheses 0? X equals negative 4/7. Doesn't make sense for the speed of the boat to be going at a negative rate, so that goes away. Second parentheses gives me x equals 7. That makes more sense. Brett can row his boat at 7 miles per hour in still water, which is a pretty good row. He's cruising right along. All right, last one. M varies directly, so it's going to be M equals K times something. What is that something? N cubed. M varies directly with N cubed. Plug in the information they tell us. M is 4. When N is 2. Nope, I don't want N. I want 2. Plug in the 2. 2 cubed is 8. Divide both sides by 8. So K is a half. Go back to my equation. Plug in the 1/2 for the K value, and now I have my generic equation that relates M and N together. So M equals 1/2 N cubed. Now just answer what they want. Find the value of N when m is, oh, they mix it up on you. Find the value of n. I guess I should say I mix it up on you because I wrote this question. Find the value of m. Find the value of n when m is 32. So plug in 32 and solve. Multiply both sides by 2 to get rid of my fraction. Whoops, I erased the wrong one. Multiplying both sides by 2 gives me 64. 2 times a half makes that go away. How do you get rid of a cube? Be cube root. And the cube root of 64 is 4. So when m is 32, n must be 4. Okay, that's it. Hopefully that helps. If not, or if you have questions as you were hearing my explanation, come see Mr. Fry or I, and we'll help clear things up. Test on Friday. Good luck.